this proportion right here, what do we need to do? So it looks like we cross multiply. So what does 16 get multiplied by? Okay. What is 16 times 3? Okay, so we have 48 equals, what is 12 times x? Okay. So once you have 48 equals 12x, Mason, what's our next step? Yeah. So we have to undo this 12 here. So what is x? 4. Okay. See, Mason, you know how to do it. Okay. Yeah.
Marius.
Marius, Mason, I mean, I see how you can get confused. Okay. Stop. So x equals 4. Okay. Now, let's talk about number 10. Okay. What do we multiply together in number 10? All right. So we have 7 times k equals, what is 21 times 8?
160k.
Okay. Once we cross multiply, we need to undo this 7 right here. How do we undo the 7?
Divide by 7.
Undo.
Okay. What is 168 divided by 7?
24.
Okay.
Great job, Marius.
Thank you, Taylor.
Okay. What I need from you, without making noise, I need you to erase the whiteboard, put those materials back, and I need you to turn in your packet to page 15. Submit a pass. Submit a pass.
Kobe. Wait, what are we doing when we're done with the videos? It was one problem. Come on.
Turn it back in. We're on page 15. Okay. All right. We should be on page 15. Okay? Up until now, everything we've done in our unit has been about congruent figures. Today, we're going to talk about what's called similar figures. Okay? So I have a question. If congruent figures means same shape, same size, similar figures means one of those is the same and one of them is different. So, same size, same shape for a congruent figure. Oh, same shape, but different size. Could you write that in? Okay. Oh, it's like not even on the board for you to see.
That's why I came over and said page 15.
All right, so do you see these two cute little triangles that I have here?
Yeah.
They are the same shape of triangle. However, they are of different size. Okay? They are similar. Now, what's going to be true about our figures? Okay? So, do you remember on our quiz what corresponds with angle Q? And you said angle angle B.
Yeah, me remember.
Okay? So we have like corresponding angles. In our similar figures, these are still going to be congruent. Okay? Our angles, in order for these to be the same shape, our angles have to remain the same. That's what congruent means, right?
Yeah.
Okay. Now, our corresponding sides. And I know you guys have talked about similar figures before. Like, this is not anything that's new for you. But with our corresponding sides, we're not the same size, so it's not going to be congruent. Does anybody remember the word that we might be writing down?
Wait, can you repeat the question, please?
Okay.
Are you talking?
Our corresponding sides aren't congruent because they're not the same size. They're going to be different sizes. However, there's something special that happens with the sides. So we have a word that goes here.
What does it start with?
Parallel?
It is not parallel, but it does start with a P.
So close.
Perpendicular. Perpendicular.
No. I want you to look at this picture down here. What? What'd you say?
Charles, say it louder.
Yes.
Mary, you took
Boy, you
Charles'
should tell me
name.
the word. Tell me a word, guys.
Proportional.
Proportional?
You said proportionate.
No,
He
I
said
thought he said
proportionate.
unfortunate.
It is unfortunate that they aren't congruent, but they are proportional.
Gosh, you silly goose.
Oh, girl, calm down.
Taylor, did you write this down?
My bad.
Oh, okay.
You see that?
Okay, so let's talk about what the heck proportional means.
Like a mouse.
Isn't that like, yeah, like how much something, how much
One out of
something
8 pieces of pie.
Okay. When you think of proportions,
Wait.
what?
Fraction.
Okay, thank you for reading my mind. When we think of proportions, fractions come to mind. So this is what I want us to do. Before we fill out the rest of that, okay? Okay, Taylor. It is important that we figure out which sides match with which sides, okay? Okay. I'm probably going to start handing out some detentions pretty soon. Like, I've talked to you as a class. I've talked to you individually. Let's go. Okay, excuse me. If I highlight AB in blue, what side over here am I also going to highlight in blue? Okay. One swoop to two swoops, right? If I highlight BC pink, what am I going to highlight pink in the other one? Okay. Which means, okay. So when we talk about proportional, we think of fractions. So I am going to make a fraction with my sides. So I'm going to take this 4 right here. And I'm going to make a fraction with 4 and what other number? Ooh, why did you pick 8? Ooh, we highlighted them both blue, right? They're corresponding. Okay? So I'm going to make a fraction with 4 and 8. Judy, can we reduce that?
Yes.
To what? We can divide each of them by 4, right? And it's 1/2. Okay. Okay, now I'm going to make a fraction.
Okay.
Excuse me, I need to cut this way. I'm going to make a fraction with my pink sides. So since I made the fraction 4 over 8, I have to grab from the small triangle again. So I'm going to make the fraction 5 over 10. Ooh, can I reduce 5 over 10? That is also 1/2. Oh.
What's the opposite of green, Mitch?
What?
What's the opposite of green?
There's no opposite in colors. Okay. If 7 is in the small triangle, what side does it correspond with? 14. So we're going to write 7 over 14. Here's the deal, people. You got to do this without me tomorrow because I'm not here. So stop.
Aren't you here, miss? Do you have a meeting?
I have a meeting.
I knew it.
Okay. 7 over 14. What is it?
Oh, put Mr. Pearson on.
Yes.
Oh. Oh.
Okay. So, hey, Marius, what's true about all of these fractions? They're all 1/2, which means our sides are proportional. This is what's called, and this is what you're going to put right here, the scale factor. Okay. Hey, Austin. Austin and Liam, I need you to stop. Okay? Do you want to get out your folder and take some notes? Okay. All right, so are these two triangles similar? Yes, they are. Okay? Okay. I'm going to give you a cute little piece of paper.
Is this burger paper?
No, it's just
Yes.
a couple extra examples. Okay. I need you guys to stop.
Oh, thanks.
Mine is like that too.
Oh my goodness, my hands are freezing. Loud doesn't matter. Okay, so I want you to look at this cute little piece of paper at number 1. Okay, fine. Let's talk about what you think about this number 1. Before we do any of the math, what do you think?
It's the same shape.
Same shape? Okay.
Different
Smaller.
sizes.
Okay, so if we make a fraction and I take this side 4, what am I going to put as its denominator?
12.
If I take this 4 right here, what am I going to put as its denominator?
12.
Oh, this is boring.
Very.
And what about this 4?
12.
Oh.
It's all 12.
Okay, hey Mason, do all 3 sides have the same ratio? Do they all have the same fraction?
Yes.
Okay, so yes, these are similar. If they all have the same fraction, then we have similar figures. Okay, so let's look at number 2. Okay, if I grab 5 to make a fraction with, what is its denominator going to be?
7.
Okay,
You can't simplify that.
we won't then. We'll leave it as 5 over 7. Now, what is the denominator for 12?
15.
Okay, we can simplify that, right?
Yeah.
Okay, we can simplify it by what number?
3.
Okay, so if we simplify this by 3, then we would get 4 over 5. Okay, hard question for you here, Bruno. Is 5 over 7 the same as 4 over 5? No. So these two rectangles are not similar. If those two fractions are not the same, when we reduce them down, then no way, they're not similar. Okay? So I want you and your elbow partner to decide if number 3 is similar or not.
Miss Holman?
Yeah?
No. But what if you like reduce the numbers and they're like equal to each other but not?
So if you reduce the numbers and they're equal,
Yeah. That means it's yes.
that means it's yeah.
Thank you.
Yeah. Okay, so set up the two fractions in number 3, see what you think. Sorry.
That just scared me.
Set up the two fractions in number 3, see what you think.
Hi, Harry.
Okay? I'm teaching right now.
I
Okay,
thought they were doing something.
I'm sorry.
They look like they're in the middle.
I'm sorry.
See you later.
But if you stop by after school or during 8th period, we have an activity. Okay.
That was funny.
Okay, I'm going to give you 30 more seconds.
Please wait.
Okay.
Sun, earth, morning, table,
Okay. So can you reduce, can you reduce those by 5? Okay, did you set up the two fractions?
Yeah, no.
Oh, interesting. Okay. 8, what are you going to put 8 over?
8 over 12.
Yeah, put 8 over 12.
It's not the same though.
Okay. How many of you vote number 3 is yes? How many of you vote number 3 is yes? How many of you vote number 3 is no? Okay. Jared, what is my denominator for 8?
Santa.
So, okay. Okay, 8 over 12. Can you stop, please? Okay, I need your help. Okay, Jared, what number can we reduce this by? 4. So we can reduce this down to 2 over 3. All right. 10. What is its denominator going to be? 15. But both of those can be reduced by, and when we reduce those, we get,
2 over 3.
okay. So, what is our answer, yes or no?
Yes.
Yes, those two proportions are the same. Or those two ratios are the same. They are proportional. Okay. All right, so we're going to go back to your notes. Okay? And we're going to answer these questions right here. Okay? So in your homework tonight, I need you to be able to look at the picture and tell me the pieces that match up. Okay? So, the corresponding angles. We did this when we had congruent shapes, okay? Which angle is the same as angle A?
Angle D.
Here's angle A. It looks like angle D is the same. So I want you to write me that angle A is congruent to angle D.
My bad. My fault.
Okay. Logan, what about angle B? Who does he match with? Angle B and angle E match. Okay. Which means, Carter, what's the last thing we need to write down? And who does he match with? Okay. So when I ask you to give me the angles, this is what I'm asking you to do. Okay. Now, for the past 10 minutes, we've been making fractions, right? Okay. We were making fractions. Now, without numbers, Mason, without numbers, we're going to make some fractions with our corresponding sides. So this is what it's going to look like, and then we'll use numbers, okay? So, side AB. Who does side AB correspond with? We already highlighted it. DE. So I just want you to make this fraction AB over DE. We're just saying, hey, those two create a fraction. And those two create a fraction that are the same as the ones that we highlighted in pink. We made a fraction up here that was BC over EF. I know they're not numbers, but when they're the numbers, we know that they're the same. And they're also going to be the same as the ones that I wrote in orange. We know that this fraction is the same. Remember, they were all 1/2. So we can write AC over DF. Ah, if only.
Alright, why? What do you mean by that? You want me to leave? I mean, I can.
No.
Boy, chill out.
Okay.
You make me happy, Marion. Okay. Now. Okay.
Boy, chill out.
Now.
Quiet.
I said be quiet.
And boy, we're just going to not say anything. Okay. Now, who thinks they know what this scale factor is, what that number is for this picture? It's already written up there. Ah.
What'd you say?
She said 1/2. Did anybody think, well, could it,
That makes sense.
or is it 2? Okay. So the scale factor, one way is 1/2, one way is 2. Right?
Yeah.
This triangle is half of the other one, or we can look at this guy as double of the other one. Okay? So when I ask you for this scale factor, if I ask you from ABC to DEF, is that 2 or is that 1/2? What do you think? Why do you think it's that?
Because it's half of
Ah, okay. So what I want you to do, let's just grab a side. ABC first because it's written first. DEF second because it's written second. Okay? So if I grab a number from ABC 4 and then a number from DEF second,
I think you're close, man.
we get 1/2. Come on.
Yeah.
Okay, so Chudier, do you see how it says ABC first? So I grabbed this number because it's from ABC. Do you see how it says DEF second? So I grabbed its matching number for its denominator. Okay, now watch this, Chudier, because now I want to go from DEF to ABC. So Chudier, which number do I want to grab first, 4 or 8?
Wait, what?
Okay, if DEF is first, do I want the 8 first or the 4? So DEF.
2, 3, 4.
Okay, Chudier, this triangle is DEF. Do you agree? So is 8 or is 4 in that triangle? 8. So we're going to write 8 first and then grab 4. So what's our scale factor for that one?
Beans.
Which is?
A can of beans.
Oh wait, no, it's not.
Literally a can of beans. Just say a can of beans.
It's just 2. Or could you write 2 over 1 and I'd be okay? Come on, Austin. I need you to put your head up. Austin, I need you to put your head up. Okay, you want a really fun symbol? Everyone draw a little squiggle right here. Austin, I need you to put your head up.
They should have done the one where he's chasing the ball.
Okay. Can you draw a little triangle right here with ABC?
Oh, that's an A.
Okay.
Whoa.
Now, ABC is similar. So we're going to write this really cool squiggle. That means similar. Okay. Now, we are going to write the triangle it's similar with. But we can't just like pick random letters. It has to be in the right order. So like, what letter did we say is in the same spot as A? A is in the same spot as D. Okay, Mason, we're going to try this again. B is in the same spot as
Whose is it?
No,
E. And C is in the same spot as F. Okay.
That's not yours.
Okay. Please. Are you okay?
Yeah, I found that.
All right. Now, honestly, I think all that's boring. Okay? Because we have to have the foundation. Okay? This is what I'm excited about. We're going to look at number 6, and then I'm going to give you a task. Okay? Number 6, we have similar figures, but we're missing a side. We got to find it. Okay? All right. So, I am going to highlight 2. And what side should I highlight blue on the other?
left.
Okay. 8 matches with?
X.
Ooh.
Why is that tough though? That is tough.
So this is what we're going to do. We are going to write our own proportion just like our warm-up. Okay? So, I'm going to make a fraction with 2 as my numerator, and what is its denominator?
3.
Let's do 2 and 3. So I'm going to go little over big. So my other fraction still needs to be little over big. So 8 over x. Okay? If I grab 2 and then 3, I need to go in the same order. Small and then big. Okay? How do we solve this? Isn't that what we just did? Like in our warm-up? What do? Taylor? We cross multiply.
Miss, I can't see.
I'm so sorry. So we're going to take 2 times x, and that's going to equal 8 times 3. What is 8 times 3?
24.
Good job, Mary.
Ooh, Trudy or asked, is the answer 12?
I am pretty sure that is the answer.
How did she get 12, Mason? We divided.
I don't know if we're going to. We'll do that for 6.
Okay, I'm just going to make a little note right here. I'm not saying that you have to write this down, but I want to emphasize that if you set up a proportion, you have to be consistent. So if your first fraction is little over big, then your second one needs to be little over big. Or if it's big over little, the second one needs to be big over little. Okay? Turn to page 17 for me, please. On page 17, I only want you to do 1 through 7.
What? There is no.
Just say
Oh.
Just
17.
What?
just say number 8.
Oh, don't do no, but you have to do number 8 tomorrow.
Oh.
Alright, Joe.
So only do 1 through 7.